Good morning, class. Today we're going to do our second lesson in geometry. Yesterday we did finding the area of a parallelogram, and a parallelogram is a quadrilateral. Here's your standard. A quadrilateral is a four-sided shape, and a parallelogram was a four-sided shape that had two sets of parallel sides. So today we're going to go to our next shape that we're going to find the area of, and that's the area of a triangle. So something that we did talk about yesterday that I want to bring up is the area is the space inside of a shape. So what I didn't say yesterday is that when I say this measurement is 6 inches, that means I'm breaking it up into 6 parts. And this side is 6 inches, so I'm breaking it up into 6 parts. And I am literally counting how many squares will be inside of that shape, okay? So yesterday I told you you had to square your answer. That is why we are counting squares inside of the shape. And they're squares because we created a two-dimensional square to count inside, okay? We're going to be doing kind of the same thing today, but we're going to be focusing on triangles. So here's your standard, and I'm sorry that I didn't put it in yesterday's video. It's find the area of a right triangle, other triangles, special quadrilaterals, and polygons by composing into rectangles. Remember yesterday we turned that parallelogram into a rectangle, or decomposing into triangles or other shapes, okay? So today we're going to be composing into rectangles, decomposing into triangles, but not necessarily other shapes. That is coming soon, okay? So first thing you need to know about the area of a triangle is your formula is still base times height equals area, but there's a twist. Base times height gives us a rectangle, and to find a triangle, you need to cut that in half or divide by 2. Because a triangle is always half of a rectangle, and I'm going to prove that to you today, okay? A rectangle or quadrilateral, all right? So we're going to start off by looking at a right triangle. So you guys all know that this is a right triangle because it has this right angle in the corner, okay? Now, right triangles are super easy to see them turned into a rectangle or square, okay? All I have to do is say, okay, if I were to continue this shape, this triangle is half of this square. So I've actually cut the shape out. Here's that right triangle, okay? If I were to use base times height, I would get the area of this whole square, okay? So here would be the whole square. Now, I don't want the area of the whole square. I just want the area of the right triangle. So if I literally chop that in half, based on the formula I gave you, I would just end up with the area of the triangle, okay? So that is for a right triangle. Now we're going to look at an acute triangle. Remember, acute triangles have all 3 acute angles. So here is our acute triangle. Now you're probably asking yourself, Miss Fisher, how are we going to find or prove that this is half of a rectangle? Well, I've already cut 2 of these triangles, and then I took one of them and cut them in half, because if I do this with those pieces of the triangle, oops, this way, you can see that this actually makes a square or a rectangle, okay? And all I did was take this triangle and cut it in half and put it on the 2 sides. So this triangle is also half of a rectangle or square or parallelogram, whatever quadrilateral you're looking at. So when I cut it in half, I'm just taking these 2 pieces off, and I'm left with the acute triangle. Now here is an obtuse triangle, And this one's a little bit harder to figure out. In fact, it took me more than a minute to figure out. So I've cut out my obtuse triangle here, and I cut two of them that are exactly the same. All I have to do is flip this over, and I have a parallelogram. Whoops, that would be the wrong way. Let's try that again. There we go, a parallelogram. Okay, so remember yesterday with the parallelogram, we talked about cutting this triangle off, putting it on this side over here, and we would have a rectangle. So the formula for finding a parallelogram, the area of a parallelogram, was exactly the same as finding the area of a rectangle or square. And now we can see that for this obtuse triangle, I cut it in half, I can find the area of that triangle. Okay, so those are the three main types of triangles. And no matter what you do, you can somehow cut it in half to find the area of the triangle. So I'm going to go in and draw, like I did yesterday, the dotted lines that show that these are in fact rectangles. Okay. All right. So moving on to the actual math part. Okay. Let's say I have a right triangle with a base of 5 centimeters and a height of 7 centimeters. Okay, here's my formula that I'm going to use anytime I find the area of a triangle. So my base is 5. I'm going to plug that in where the B is. Then that's times my height, which is 7. And I'm going to divide that whole side by 2 in order to find my area. So let's work that out. What is 5 times 7, everyone? It is 35. And I'm going to divide that by 2. Now I know this is an odd number, so I'm going to end up with a decimal or a fraction, which is fine. We've dealt with both of those this year. So I know that half of 30 is 15. I know that half of 34 is 17. So it's probably, with one left, I'm going to cut it in half, and I will have 17.5. But what if you don't know how to do that? You can always set up your division problem over here, because that's something we've practiced this whole year. 2 goes into 3, 1 time. 1 times 2 is 2. Subtract, I have 1 left over. Bring down the 5. 2 goes into 15, 7 times. 7 times 2 is 14. Subtract, I have 1 left over. I can put a decimal, drop a 0. And 2 goes into 10 5 times, which is 10. Subtract, and I 0 out. Okay, so my answer for the area, because that's what I'm finding, is 17.5. My label is centimeters. And I know that inside of this, I was counting squares, so this is squared. Okay, 17.5 centimeters squared. Now, for that acute triangle, it's going to look a little bit different when you do the labeling on it. Your height is going to be right here in the middle, because a diagonal line cannot be your height. Ever, 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 as far as I can think of in geometry. Okay, so the base of this is going to be 4 centimeters. And the height is 6 centimeters. Whoops, that M looks funky. And then we're going to plug our base and height into our formula for finding the area of a triangle. So my base is 4. I'm going to multiply that by my height right here, which is 6. Then my formula says I have to divide the whole thing by 2 in order to find my area. Okay, so 4 times 6 is 24. When I divide by 2, I know that 24 divided by 2 is 12. My label is centimeters. And I know that I was technically counting squares, okay? And so my answer has to be squared. Okay? All right, now for that obtuse triangle. They're the harder ones to draw too. You always have to build that obtuse angle first. For these, finding your base and your height are a little bit different, okay? Your base is going to be this no matter what, all right? So we're gonna say that this base is, let's do 4 centimeters again. But this time your height is going to be from the lowest point of the triangle up to the highest point of the triangle. And if you remember on your parallelogram, that would be how you would show that anyway. So your height looks a little different when they label it on an obtuse triangle. So we're going to say that this height is 5 centimeters. Okay? Yes, I love centimeters. So now we're going to plug these numbers into our formula. So our base is 4 centimeters times our height, which is this 5 centimeters for the H. And then my formula says I have to divide the whole thing by 2, because remember, a triangle is half of a rectangle, in order to find my area. So 4 times 5 is 20. I'm going to bring over the 2 because I haven't used it yet. And I know that 20 divided by 2 is 10. My label was centimeters. And I know that if I were to go in and draw all the lines, I would actually be counting cubes because they're 2-dimensional. So I have to put squared. Okay? And then that is my answer. So you are going to have a page of practice of all 3 types of triangles. They will label both your base and your height, okay? Just as a side note, most of the time when you're dealing with triangles, you're dealing with base and height, but you will also sometimes see length times width. However, this is more of a rectangle or quadrilateral labeling. They are exactly the same. The length is the same as your base, and this is height. Length times height. Height is the same as height, okay? We'll get into width soon enough. We're not there yet. All right. Please let me know if you have any questions. I know this is a new concept. This is the first time we're actually really looking at dealing with a formula, so that's new. If you need me to work more problems out on the Zoom classroom tomorrow, please let me know. And you've got this. I believe in you. You can do this. Good luck.